Welcome to this lecture. So in this video, I will discuss Laplace transform of complex exponential signal and its ROC. The complex exponential signal is expressed as e power j omega t into u of t, where u of t indicates that the signal is exists only right-sided. So that is the time axis 0 to infinity, so which we can also call it as a causal signal. Now we'll try to find Laplace transform of this complex exponential signal e power j omega t. That is Laplace transform of x of t equals to integral over 0 to infinity x of t e power minus st dt. Now x of t given as a complex exponential signal e power j omega t, that we write here integral over 0 to infinity e power j omega t u of t e power minus st dt. So in the limits 0 to infinity, u of t value is 1. So u of t is the unit step signal, so whose value is 1 when t is greater than or equal to 0, and u of t value is 0 when t is less than 0. So based on this definition of unit step function, so we write u of t is 1 within the limits 0 to infinity. Now the function simplifies as integral over 0 to infinity e power j omega t into e power minus st dt. Now we further simplify this expression integral 0 to infinity. So this function becomes exponential of minus of s minus j omega t dt. Apply the integral to this exponential function gives us e power minus of s minus j omega into t divided by minus of s minus j omega over the limits 0 to infinity. After applying the limits, so we'll get e power minus infinity is the upper limit minus lower limit is e power 0 divided by minus of s minus j omega. We further simplify it as Laplace transform of x of t equals to e power infinity is 0 and e power 0 is 1. So we write 0 minus 1 divided by minus of s minus j omega. So that gives us 1 by s minus j omega. Therefore, Laplace transform of e power j omega t into u of t is 1 by s minus j omega. Now we also write the ROC for this exponential function from the expression integral over 0 to infinity e power j omega t into e power minus st dt. So this expression we use to find the ROC. So in this expression we have the two exponential term. First term is e power j omega t and second term is e power minus st. As we know that magnitude of e power j omega t is 1 regardless of the value omega t. Whatever the omega t value, so irrespective of that, magnitude of this exponential function is 1. So now the function is integral over 0 to infinity e power minus st dt. So the function value will be finite only if this s value is greater than 0. This s indicates a real part of s and this should be greater than 0. So real part of s it indicates sigma and the sigma value greater than 0 integrate function of this e power minus st dt becomes a finite. Now we'll draw the ROC plot for this complex exponential signal e power j omega t. So this is S plane and x-axis is sigma, y-axis is j omega and this is the origin point. The ROC is exists for the given function if sigma is greater than 0. So this is indicated in this figure using the horizontal lines. So this is the shaded region. We say the region of convergence or region of existence of Laplace transform for the exponential function e power j omega t u of t. Finally, we can write it as Laplace transform and its ROC for the exponential function e power j omega t. E power j omega t u of t. The Laplace transform for this is 1 by s minus j omega and ROC is s greater than 0. Similarly, we find the Laplace transform for x of t e power minus j omega t u of t. By the definition of Laplace transform, so we can write that Laplace transform of x of t equals to integral over 0 to infinity x of t e power minus st dt. Now in place of x of t, we consider the exponential function e power minus j omega t u of t into e power minus st dt. So in the region of 0 to infinity, so u of t value is 1 and we write the integral function from 0 to infinity as e power minus j omega t into e power minus st dt. Integral 0 to infinity and this function simplify it as exponential power minus of s plus j omega t dt. Now we apply the integral to this exponential function. So we'll get exponential of minus s plus j omega t divided by minus of s plus j omega over the limits 0 to infinity. Now apply the upper limit. So gives us e power minus infinity minus lower limit is 0. So that gives e power 0 divided by minus of s plus j omega. Now we'll further simplify it to get the final value of Laplace transform for the exponential signal. So equals to e power minus infinity is 0 minus 1 divided by minus of s plus j omega. That gives us 1 by s plus j omega. This is the Laplace transform for the complex exponential signal e power minus j omega t. So we write in e power j omega t u of t Laplace transform is 1 by s plus j omega. Now we also write the ROC for this function from the expression integral 0 to infinity e power minus j omega t into e power minus st dt. Integral 0 to infinity e power minus j omega t e power minus st dt. If we observe this expression, so in this case magnitude of e power j omega t is 1 irrespective of the value of t. So then the expression integral 0 to infinity e power minus st dt becomes finite only for the values of s greater than 0. For s values greater than 0, so this function is exponentially decaying, and as time t tends to infinity, this value is converges to 0. Now the ROC is exists for s greater than 0. So meaning is that s is the real part of complex quantity sigma plus j omega, and this real part of s indicates sigma. So for sigma greater than 0, only the ROC exists for this complex quantity. So this is sigma axis, and this is j omega axis, and this is origin. Now the ROC exists for sigma greater than 0. So this is sigma. For sigma greater than 0, the ROC is exist. So we indicate the region of convergence as shown in figure. So this gives the ROC, this region of convergence for the complex exponential signal e power minus j omega t into u of t. So finally we can write the Laplace transform of e power minus j omega t u of t is 1 by s plus j omega, and its ROC is exists for s greater than 0. So this is all about the Laplace transform of complex exponential signal e power j omega t and e power minus j omega t, and the corresponding region of convergence in S plane. Thank you.